Ukmt IMC 2020, again from number 11. If you have any question, feel free to leave any comment on this video. Even you have question about from number 1 to 10. So number 11, start at 1 to finish at 7. So we go from 1 to 7. On the way, we need to move to the higher number, the Jason square. So from 1 to 2 or 3, and 7 from 5 or 6. So this is a better idea. We consider only this route because from 1 to 7, even it is not like very complex, it's better to think with the small numbers number. So from 2 to 5, let's start from 3 because it's closer. So 3 to 5, there are one numbered. So we can go directly 3 to 5 or 3, 4, 5. So 3 to 5, we have two different ways. 3 to 6, we have a 4, 5, 6. We cannot go directly to 6, so we need to jump over 4, 5, or 4 and 5. So 3 to 6, three different ways. So when you think about the number of ways, we need to consider how many steps we make. So for example, 3 to 5, we have like just 1 step or 2 steps. 3 to 6 or so, that we cannot make 1 step. So 2 step, 2 step, 3 steps. So this is a good way to think, not to lose where we are going. So from 2 to 5, we have 3, 4, 5. 3, 4, 5. So the shortest way to like 2 steps. So if we make 2 steps, 2, 3, 5 or 2, 4, 5. Here there is no 5. 2, 3, 5 or 2, 4, 5. And if we make 3 steps, 2, 3, 4, 5. So 3 different ways. 2 to 6, we have 3, 4, 5. But here we cannot go to like 2 steps. Unless but because of 4, we can go to 2 steps. And if we go with 3 steps, 1, 2, 3, like 2, 4, 6. 3, 5, 6, or 4, 5, 6, 1, 2, 3, 4. And if we want to make 4 steps, 3, 4, 5, 6. So 1, 2, 3, 4, 5. So altogether 13. Let's go to the next one. Farmer Fatima, chickens and goats. I sold 80 animals. So chicken and goat sold is 80. Now there are 200 fewer legs. Chicken has 2 legs. Goat has 4 legs. Altogether 200. C plus 2G could be 100. I divide by 2. So here I can make the system equation. When I subtract them together, negative G equals negative 20, G is 20, C is 60. So how many goats? 20. And the 13. Half of 1.6 times 10 to the power of 6. If this is 1.6 plus 10 times 6, for example, then you need to do this heart-shaped calculation. So in this case, 0.8 plus 10 to the power of 6 over 2. Like you need to apply divide by 2 to each number. But when you apply this divide by 2 on this multiplication, we do only one number. So 0.8 times 10 to the power of 6. But this is not proper scientific notation, so we put 0.8 as 8 times 10 to the power of negative 1 times 10 to the power of 6. So 8 times 10 to the power of 5. And let's go for the next one. The result calculation. In this case, I mean, if you calculate all them together, you may find the result, but no need to do that. We have very limited time. On the previous video, I explained you how to find the numbers of this divisible by some specific numbers. Here we have this number 9, which means this is the multiple of 9. Of course, they are multiple of 11, 13, 15, 17, but this is too difficult to figure it out. What is the multiple of 11, multiple of 13? 15 is fair enough because this is multiple of 3 and multiple of 5. But this one, anyway, we should find the number which is multiple of 9 or multiple of 27, something like that. So on last video, I explained that multiple of 9 is very easy to figure it out because we can add all these digits. 8, 1, 8, 5. This should be multiple of 9. So this one, so this is 25 plus n. It should be multiple of 9 or multiple of 27. Whatever it is, n should be 2. Number 15. Triangle PQR has been divided into 25 congruent right angle triangle. Oh, so this each one is right angle. So this and like this. So this one, when we add them together, is right angle, 90 degree. So this and this did also right angle. So it didn't say, but now it's very clear. PQR also right angle triangle. So RP 2.4 centimeter, which means that this smaller hypotenuse is 0.6 centimeter. And here also 0.6, which is 1.8 centimeter. So this is 0.6 times 4, 0.6 times 3. This should be 0.6 times 5 because 3, 4, 5 ratio is the Pythagorean number because this is right triangle. So length of PQ, 3. So we didn't solve it fully, but we know what is the number. 16, 1 over 9 plus 1 over 11. So it's easy to add them together. 11 plus 9, so 20 over 99. But it's not very easy. What is that to figure it out? What is this number? So actually, this cannot be the answer. It can be answer only number E because, you know, this is the simplest form, 20 over 99. When you have like different number than number 2 or 5 on the denominator, actually it never finishes. It's a repeated decimal or endless decimal. And there is no endless decimal, but so repeated decimal or endless decimal. So here 20 over 9 times 11, so 3 squared times 11. So those are not 2 or 5, but whatever it is, as it has other than 2 or 5, those are like infinite, the decimal. So only this can be the answer. But if you didn't know about this property, then you can also figure it out like this. 20 over 99 equals x, then 20 equals 99 minus x, but 99 is 100 x minus x. So among those numbers, when we multiply 100, subtract its own number, then we need to get 20. For example, here, when we multiply 100 is 20, minus 0.20 cannot be 20. So this cannot be the answer. This one, 0.202020, this recurrence decimal, when we multiply by 20, 20 times 20, 20, 20 again, and itself is 0.2020. So when we subtract them together, then the last result is 20. So this is how we know. So it's better to remember that when only if we have the factors of number 2 and 5 on denominator, we can get finite decimal. So all of this, like 100, 10 over 100, 1 over 10, 20 over 100, 1 over 5, 20, 20 over 100, whatever it is, 101, 5. So 1, 1, 1, 1, 1, 1, 1, 20, 20, 20. So we can tell because whatever we make, all the decimal has only the power of 10. Power of 10 means 10 is already 2 times 5. So power of 10 is 2 power and power of 5. So only it has 2 and 5. So if you have like 3 or 7 or 6, let's say, then this is not the finite decimal. It goes forever. So let's go for the next one. Knave of hearts stole some tarts. Let's say n tart. He ate half of them. So now there's only half of the tart and half a tart more. So he ate 1 half tart. Diamonds have half of them and 1 half. And half of them and another half and just 1 tart. So this is the one. So let's multiply by 2. And now this is a 3. Let's multiply by 2. Now this is 7. Let's multiply by 2. Then n equals 15. Does it make sense? I mean, let me calculate just once more, just to check. Because he had half of them, let's say 7.5 and 0.5. So now we have only 7. 3.5, 0.5. So now we have only 3. 1.5 and plus 0.5. Now we have only 1. Yeah, it makes sense. But just the half of the tart was the decimal. Diamond shows isosceles right angled triangle. This is y. Interior of triangle split up into identical square congruent. Those are squares, so identical. So this all same, which means this triangle is right isosceles triangle. So we can tell this is 45 degree, all 45 degree. So originally the original triangle was also isosceles right triangle. So this is why isosceles right triangle has the ratio of 1 square root of 2. So in this case, x should be y over square root of 2 to become y. So here, square root of 2y, square root of 2y. So original triangle has the area of y over square root of 2. So y squared over 4. This is the original area. And now we need to, so now we have the smaller 1, 2, 3, 4, 5, 6, 7, 8. So 8 smaller triangle. But this 8 smaller triangle is 1/4 of the original triangle in terms of the length. So 1/4 length means area is 1 over 16. So this was the original triangle area. Then the one of the smaller area is 1 over 16 times, now we have 8 of them, so 8. So this, the white area is 1 over y squared over 8. So now we can subtract from y squared over 4 minus y squared over 8. So it becomes y squared over 8. So let's go for the next one. Number 19. Two squares, 48. So this is again 48, 48. If this is 24, this becomes 24 square root of 2. Again, this is isosceles right angle triangle. And it touches here. But you know, this is right triangle because it's square. And this is right triangle because they are tangent. So this should be right triangle, which means this one is square again. So in this case, what we can do, let's say this is R, this R, and this R. Because this is like isosceles right triangle again, 45 degree. So this one, 24. Oh, so R, 12. Let's go for the next one. For any fixed value of x, following for expression, largest value. So x squared minus 1. This was the formula, like x plus y, x minus y, like product of sum and difference becomes the difference of the squares, like this. So this was the formula. So the first one becomes x squared minus 1, second one x squared minus 1 over 4, x squared minus 1 over 9, x squared minus 1 over 16. So 1 over 16 is the smallest number. So when we subtract the smallest number, the value remains the largest. So this is the largest number. Because x squared is already positive number. And number 21. For semicircles, one radius is 2. So smaller was radius 1, larger one is radius 2. So 2, smaller 1, 1, 2. 2, like this. Total area of shaded region. Okay, then when I shade here, 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 when we combine them together, assemble them together, actually it becomes one full circle, this is a smaller circle. So the whole semicircle area is pi r squared over 2. This is this whole area. But now we subtract pi r squared, one full circle, minus this rectangle, 1 times 2. So 2 pi minus 2, pi minus 2. And number 21, 23. 22. This shows a regular pentagon. Regular pentagon has 3 sub-triangles. We can divide them into 3 triangles from one vertex. So the whole interior angle becomes 180 times 3, 540. Divide by 5 to find one internal angle becomes 108. So this is 108. If you figure it out, what is this shape? Actually, this is just quadrilateral. I mean, it has 4 sides and 4 angles. So this is quadrilateral. But it has this convex angle, so we can call it convex quadrilateral. So anyway, what it means, the whole interior angle, the sum of the whole interior angle should be 360. So this, and this should be 360. Let's say A, B, C, C, D. A, B, C, D, 360. And now we want to know this. So if we know the angles, the measurement of angle D, then we will know ABC. So this is 18 degree. So D becomes 360 minus 108, 252. So D is 252. Ooh, actually, which means 108 is the answer. Okay, let's go for the next one. 5 congruent triangles and 3 different ways. Perimeter. So now, let's say this side is x, then this is square root of 2x, because this is again right angled isosceles triangle. So for P, there are 2 short one, 2x, and 3 larger one, 3 square root of 2x. Q, 1, 2, 3, 4, 5, 6, so 6x plus 1 square root of 2x. Okay, 1, 2, 3, oh no, 3 square root of 2x plus 1, 2, 3, 4, 4x. If we compare only this and this, we can figure it out. P is smaller than R, so R larger perimeter than P. And this one, 6x, let's compare with R. So for example, this has 4x plus 2x plus the square root of 2x. This one, 4x, 2 square root of 2x plus the square root of 2x. This and this are common, so we can compare only this and this. 2x is x plus x. I mean 2x is 2 is 2, but square root of 2 is almost like 141. So when we double it, it's 2.8 something. So this is larger. Oh, okay, so R is larger than Q. So now we need to compare P and Q. 2x, so here 2x plus 4x plus square root of 2x. Here 2x plus square root of 2x plus square root of 2x. So 2x and square root of 2x are common, so now we will compare 2 square root of 2 and 4. 2 square root of 2 is 2.8 around, and this is 4. So Q is larger. So we can say PQR. So this is ascending order, PQR. Let's go for the number 24. Positive integer. Okay, here, let's say on the right side, we can find the common factors there. This is a 2 to the power of n plus 2 to the power of n times 2 to the power of 2. So 2 to the power of n is common factor 1 plus 2 squared, which means 2 to the power of n times 5 equals 10 times 2 to the power of m. So 2m plus 1 equals 2 to the power of n. So what is the difference? Number 1. And number 5, 25. Diagram shows PQ or STEU. Inner circle radius 1. So outer circle radius of 2. So they share the center, concentric the circles. So like this. When we do it together like this, because those are very symmetric, it says that 3 lines of symmetry. So for example, if we set it like this, let me draw the line a little bit better. So when I draw the line like this, we can tell all of them are like not all of them, like they have vertical angles between them. It looks like some symbol. So these 2 are staying with here. These 2 are staying with here. So these 2 are staying with here, which means all together they have like this 6 small angles. 12 small angles. So let's call this a small angle x, 360. So x becomes 30. So for example, this is 30. And this is 1. And this is 2. So let's find this first because it's easier. So that is the 1, 2, 3. When we put them together, it becomes a semicircle. So pi r squared over 2 is this already, this shaded region. So now we need to find this smaller 6 triangles. So this is 1 and that is 2. Let's say it has right angle here because it's easy for us since this is special case of this right angle triangle with degree 30. So this has, so usually we set x square root of 3x, 2x. But the triangle what we have has hypotenuse with number with 1, measurement 1 unit. So maybe x becomes 1 over 2. So here, which means that this height becomes 1 over 2. and base is the larger radius, which is 2. So this triangle area is 1 over 2 times 2 times 1 over 2, and we have 6 of them, 6, like this. So 2 pi plus 3. That's it.